Okay, so one important information from Professor Selva Kumar is that these two exercises will be your last. That means this is the last class wherein we will discuss these two techniques of 2D plot and curve fitting. And from next class onwards, you will be just practicing it. There will be no other classes. So exercise 14 is the 2D plot, which you can see over here, and exercise 15 will be the curve fitting. You are expected to practice these exercises from 1 to 15 for the remaining sessions. Okay, so let's begin. So in Matlab, there are techniques of defining a array or a list. So here you see we have two techniques. So here we will show 2D plot using lists. Okay, so you will have a set of points in the x-axis and set of points in the y-axis. And then we will write down the function which relates y and x, and then we will plot the function. So we have two ways to represent a vector or a list. The first is using the Linespace command. So the first entry 0 is the initial point. So here we are taking 0, and this is the final point 2 pi. The last one, 100, which you are seeing, is the number of points which we want in this vector. So this vector will have only 100 elements, which will be equally spaced. So this difference between any two element will be the same, or in other words, this will be in AP with a common difference. So it will have only 100 elements. Okay. Here, which you see x1 as 0 to 100 in intervals of 0.01, where 0 and 100 will be inclusive. So this will have 101 elements, unlike this representation where you will have only 100 elements. Okay, so you can have plots, you can define arrays, vectors using the Linespace command or using this semicolon representation. But there is a difference. As you can see here, the length of the element is decided in the syntax itself. Here it is one more than the final element. Okay, so let's start here. Huh. So you see, once we have defined the array x in Linespace, first let's see the Linespace command. And you see length x I have just written here. This length x will count the number of entries in the vector. Okay, so let's run this. So what, all of you can see this plot? Please give me a yes. Hello? I understand post lunch session can be drowsy, but little bit
Yes,
of
sir.
response from your side is good. Thank you. So you can see this plot, and this is using the Linespace command. And you can also use x1, and it will also generate. What you will appreciate that now there will be more number of points, because see, this x1 is going from 0 to 100. This x plot, if you see, is from 0 to 2 pi, right? But here what I have written for x1 is 0 to 100. That means more number of cycles, right? So let's modify the code and see what happens. And you will see that we will have 100 by 0.01 plus one number of elements here for x1. Let's run it. So you see more number of cycles, right? Till 100. And you have 1001 elements, right? So these are the two ways. Any questions till here? So if there, okay. So you can also change the function. right? And you can expect a different plot, right? So it is phase shifted by pi by 2, right? You can play with this as you want. You can just write x1 also. In that case, it will be a linear plot. Let's see what happens here, right? So this is one way of generating 2D plot. Here you see x1 square. Oh, here it will be bitwise. So I have to add this dot to say that each element will be squared. When I just put the exponent, it was as if vector was getting squared, which MATLAB was not able to understand. So this bitwise operator, which was taught to you in the previous class, is used over here. So please note this step. It's good thing that we ran into this. And once this is done, any questions? Please ask. If you have any doubts, please ask. So this is 2D plot. And now we will talk about curve fitting. So curve fitting is important when you are doing collecting some experimental data from some machine, from some apparatus. So let's say you have some experimental data in X and Y, represented in X and Y. So X is the some important parameter which you are changing, 1, 2, 3, 4, 5, let's say. Pertaining to these parameters, you are getting some readings, 5.5, 43.1, 128. So these are also vectors. As you can see, we have just added a space and a square brackets, right? So this is one way this set of experimental data is given to you. You are interested in understanding how this experimental data changes. So a very simple polynomial fitting we will look for. So polyfit gives you the polynomial which will best fit this data, okay, such that the error is minimum. And what is the data which we want to fit? We want to fit data in X and Y, okay? And the last entry is the order of the polynomial. So you can fit the experimental data using quadratic, using linear, okay? You can using biquadratic function. Here, for example, we are choosing a cubic polynomial. So this polyfit of this data xy using cubic polynomial is stored in this vector p. What is being stored? So general cubic expression is ax cube plus bx square plus cx plus d. So p is storing the coefficients a, b, c, and d. This is what you have to remember. So this fit will MATLAB will do, and it will give you the coefficients, or in other words, the polynomial. Now what we will do, once we have the polynomial, we will feed again a list from x to going from 1 to 5 again. It finer steps. Here see you have data with spacing of unity. Here we have around 1/10 of that. So 1.1, 1.2 till 5. And then there is another command which is known as polyval. Here for the coefficients which you have obtained, coefficients of this cubic polynomial which you have obtained using polyfit, that coefficients will be multiplied by these entries. What are the entries? So first it will multiply, it will input x2 as 1 and it will calculate a y2. Next it will input 1.1 and it will again calculate y2. So you will generate again a polynomial. So this is the polynomial which we have obtained after fitting, and this is the experimental data. And we have plotted them in the same plot. Please note the command. First one is the experimental data plot, which we have marked using a data cursor O. You can change it. This is just for representation. You can add a triangle, you can add T, whatever. So very simple is O. So just I'm marking the experimental data points with O. And the fitted curve, the polynomial, the cubic polynomial is x2, y2. Let's run this. So as you see, so this is the experimental data which you have obtained, and this is the fitting, the cubic fit. We see that it's almost, roughly you can see that the standard deviation is minimized because one point is here, one point is here, almost to the same extent. There are not much outliers here. So this fits pretty well. Okay. And this is how you do a general curve fitting using polynomials. The command is polyfit. Remember, this is curve fitting only using polynomials, no other function. Any questions? Any question? So, okay.